Chapter 5 has a pretty big extension to it, which is called linear programming. And this is a very major topic in mathematics. And it's something that is included in Chapter 5, but I like to do separate so that we can pay special attention to it because it is so important. Basically, linear programming is taking what we have already done in Chapter 5 and applying it to real world situations. So let's kind of take a look at it and see what it looks like. So Jocelyn's jewelry store makes rings and pendants. Every week, the staff uses at most 500 grams of metal and spends at most 80 hours making jewelry. It takes 5 grams of metal to make a ring and 20 grams to make a pendant. Each ring takes 1.5 hours to make. Each pendant takes 1 hour. The profit on each ring is $90 and $40 for each pendant. How many rings and pendants should be made to maximize the profit? Okay, so there's a lot going on, which is kind of why it's laid out in all these different steps. There's going to be 6 steps to kind of work through each one of these problems so that it doesn't seem overwhelming. But the goal of all of these is to go ahead and say, how do I maximize the profit or how do I minimize the cost? So these are your real life situations dealing with different constraints, okay, or different things that I have a limited amount of so that I either want to maximize or minimize. Okay, so step 1 is to define the variables. So the two things that we are talking about, okay, which we see right away are rings and pendants. So I'm going to let X stand for my rings, and I'm going to let Y stand for my pendants. If you want to let like R equal rings and P equals pendants, that's 100% fine. I just like to kind of stick with X and Y because we're going to be graphing these. So then the next part is kind of the trickiest part, and it's writing the constraints or things that I have a limited amount of. So by constraints, I mean what is limited? Okay, well, I have a limit of 500 grams of metal. Okay, and I also have a limit of 80 hours. But right now I'm just going to kind of see, okay, what deals with 500 grams of metal? Okay, well, I've got 5 grams to make a ring and 20 grams to make a pendant. So I'm going to say 5x for the 5 grams it takes to make a ring plus my 20 grams to make a pendant, so 20y. And I have at most 500 grams, so that means all of this has to be less than or equal to 500. Okay, so that is my constraint dealing with my metal. Okay, I also have another constraint that deals with hours. So I only have so many hours that I can have my workers working, and that's 80 hours. So rings take an hour and a half, and pendants take 1 hour. So keeping that kind of same format, I've got 1.5x plus 1y has to be less than or equal to the 80 hours that my workers can work. Okay, so that one is dealing with hours available. So those are kind of my two big limitations, okay? But I'm also going to write 2 more inequalities, and I'm going to use these inequalities on every single problem I do, okay? Because we are talking in real life situation, the number of rings I have and the number of pendants I have has to be positive. So I'm going to say x is greater than or equal to 0 and y is greater than or equal to 0, okay? So all together, I'm going to have 4 inequalities, and the x and y greater than or equal to 0 has to be in all of them. Okay, so make yourself a little note. These 2 are the special ones. Okay, those mean they have to be positive because we're talking in a real life situation. So step 1 and step 2 are taken care of. The next step is going to be actually to graph these. Okay, so, I don't know. I have to graph 2 of them. Okay, so if I kind of go back and I do some of my side work, my first line dealing with metal, to graph that line in standard form, I like to make an XY chart. Okay, and sometimes it's helpful because you guys probably aren't writing in colors. I'm going to label that first line my line number 1, and then my work to go with line number 1. Okay, so if I use an XY chart, if I don't make any rings, then I would have to make 25 pendants. And if I didn't make any pendants, then I would have to make 100 rings. So there's my first 2 kind of ordered pairs. And if I do the same idea for my second equation here, when you guys do this for your project, it's a really nice idea to number them so that you can keep it clear for yourself. Okay, so if I plug in 0 for x for my second equation, then my y is 80. If I plug in 0 for y, then my x winds up being 53 1/3. Okay, keep the exact number there, and then we can kind of estimate it when we actually graph it. So let's go ahead and graph that. since I said that my rings are my x's, I'll go ahead and label rings on the x, and then my pendants on my y's. And what you want to do is you want to make this graph as big as possible in the space provided. So the biggest x that I need to get to is 100. So I'm going to go by fives. I've got 10, 20, 30, 40, 50, 60, 70, 80, 100. Perfect. And the biggest y coordinate I need is 80. So I'll kind of go by tens again. So I've got 10, 20, 30, 40, 50, 60, 70, and 80. Okay, so I'll graph that first set of data, so that dealt with metal. So I had 0, 25 there, and then I had 100, 0. Okay, these were less than or equal to's, so this is going to be a solid line. Okay, so there was my line 1. Again, if you want to label that line 1, that's not a bad idea. And then line 2 was at 0, 80. And then 53 1/3, so here's where you get to guesstimate, 53 1/3, 0. Again, that was less than or equal to, so that's a solid line. And I can label that number 2. Now my third and fourth lines are the greater than or equal to zeros. So that means I'm in the first quadrant, so we don't really need to graph those. But when we go to shade, we're going to want to keep that in mind. Okay, so if I test 0, 0, these are both less than or equal to's. So if I test 0, 0, that's going to be below each of these, but then again, I had greater than or equal to 0, so my shaded region, my feasible region, is all in here. Okay, my feasible region is all in here. And before I move forward, what I want to be able to do is name the vertices. So that's kind of this other part up here, is graphing the system with the vertices. And the vertices are the part that kind of bind my actual shaded region, my visible options. So right now I can see that I have one ordered pair down here at 0, 0. Okay, so I know that one, so I can list that. That one's easy. I know this one, which I put there, so I know that that one's 0, 25. I don't know this one, but I know that this one is 53 1/3, 0. Okay, so I need to find that last vertex, okay? And it's not a good idea to guesstimate it because that's not exactly right. But I know that this point of intersection is the solution to those two lines. Now that's exactly what we've been working on, is finding the point of intersection when you're given two equations. So if I have the two equations from before, 5x plus 20y equals 500, and 1.5x plus y equals 80. Okay, to solve them, I can just put in equal signs instead of inequalities. So now I have my two equations, and you can use substitution or you could use linear combinations. Okay, I'm going to multiply my second row here by 20. Okay, if you had wanted to solve it and substitute it, that's 100% fine. I just kind of like linear combinations, so I'm going to do it that way. So this new equation is going to give me 30x plus 20y equals 1600. And then I'll just rewrite my 5x plus 20y equals 500 from before. To get my y's to cancel, I'm going to have to subtract. So I've got negative 25x, my y's cancel, equals negative 1100. Divide by negative 25, and I'm going to get x equal 44. Okay, so now that I have my x, I'm going to need my y, and I'll plug it into this second equation right here. So I've got 1.5 times 44 plus y equals 80. So I'm going to get y to equal 14. So I now know that this ordered pair right here is 44, 14. Okay, so now that I have graphed my lines and I have all the vertices, okay, that I need, now I'm actually done with step 3. So step 2 and step 3 are the hardest part of it all. Okay, please notice that I did not include this point up here or this point up here. Okay, I do not need those because it's not attached to the shaded region. Okay, it's only the ones that are included in your feasible solution, okay, next to the shaded region. So you do not use those two that we did not write down. Okay, so now that we have our set of options, okay, we've got 4 kind of options here, we want to write an expression to be maximized or minimized. Okay, well, the question asked us to maximize something. So if we go back to our story problem here, it asks us to maximize the profit, okay? And we did not use the information that dealt with the profit for the ring is 90 and 40 for the pendant, okay? So there's going to be some information left, and we're going to save it till now. So the profit is talking about, it was $90 for the ring. So 90x for the ring plus $40 for the pendant, which is Y, will equal my profit, okay? And that's what we're trying to maximize here. So now what I'm going to need to do is my answer is going to be one of those 4 ordered pairs from our feasible solution. So I'm going to write those all down. So we had 0, 0, we had 0, 25, we had 44, 14, and we had 53 and a third, 0. Okay, so those are the 4 we're going to use. You don't necessarily use these other 2. Okay, it's just kind of like a maximum. You're never going to have more than 6. So now I'm going to do is plug these ordered pairs into this solution. So if I don't make any, I'm not going to make any money. Okay, if I make 0 rings and 25 pendants, I'm going to make $1,000. If I make 44 rings and 14 pendants, I'm going to make $4,520. Okay, now the next one comes 53 and a third. Yes, I can plug that into the equation, but does that make sense? Could I actually make 53 and a third rings? No. So what you're going to do is you're going to use the next feasible option, which would be 53. Now I rounded down because our equations, our inequalities said less than or equal to. Okay, if it had said greater than or equal to, I would have rounded up. So I'm going to round that to 53, 0, and then that would give me a maximum of $4,770. Okay, so all I did is plug those ordered pairs into the expression we wrote above. So if I want to maximize my profits, it should be pretty clear to see that this option gives me the most, right? $4,770 would be the most. So now to interpret my results, my last step, I'm going to be very specific. So I'm going to say for Jocelyn, because that's our jewelry store, to maximize her profits, because that's what we're talking about, she should make 53 rings and 0 pendants for a profit of $4,770. Okay, so you do need that entire sentence. Okay, there isn't really a way to make that shorter because you need to tell me what's happening or maximizing her profits, what she should do, 53 rings and 0 pendants, and how much that profit is going to be. So that is just one problem, which is all you need to take notes on for tonight. So go ahead and jot down some notes or some questions you have at the bottom of this page, and we'll go over one more example tomorrow. So linear programming at its finest.